Welcome back to the exam walkthrough. We're going to be doing 2023 October Unit 1 question number 13. You can do the question yourself first and then watch me do it. For the mark scheme and the examiner report, you can go to the end of the video. Tennis players can practice using a tennis ball machine. The machine projects tennis balls horizontally from a height of 2.54 meters as shown. Show that the time taken for the ball to reach the ground is 0.7 seconds. Okay, so whenever you see a projectile motion question that looks something like this, I like to call it half projectile motion question. So it's kind of like half projectile path. So remember that the initial velocity is equals to, the initial velocity is equals to ux, okay? And the velocity in the y direction is going to be equals to 0 initially. Okay, so if this is equals to 0, then the initial velocity is just the horizontal velocity. So now what we can do is we can use the equations in the y direction. S U V A T. S we know is going to be minus 2.54 meters. I'm going to explain how we get that in a bit. And then U we know is going to be 0 in the y direction initially. V we do not know, and then acceleration due to gravity is minus 9.81, and time is question mark. Okay, let's talk about this now. Okay, so this is going to be my reference level. Basically, reference level is like my 0. This is my 0. So initially my displacement is 0. When my ball reaches here, my vertical displacement, now I'm going to take down as negative and up as positive. So when I reach this point, let's call this A and let's call this B. So when I reach B, my displacement is going to be minus 2.54. Okay. The displacement S here, you can actually write change in S. I think that would be better. Okay. Even though in A level you're used to writing S, I recommend writing change in S because that's the actual meaning of that displacement there. So that's going to be equals to the final displacement minus the initial displacement. So the final displacement minus 2.54 minus 0. Okay, and we get minus 2.54. So the change in displacement is going to be minus 2.54, but since you're used to writing S, you can write that S is equals to minus 2.54. Okay, so I hope that is clear. Now for the equation, we can use S is equals to ut plus half at square. This is going to cancel out because u is 0. We're going to end up with minus 2.54 half minus 9.81 t square. The minus will cancel out. And then we're going to have 2.54 times 2 divided by 9.81 and then square root. So we're going to get the answer as 0.72 seconds, which is approximately 0.7 seconds. Now part II tells us the ball lands on the ground at a horizontal distance of 17.89 meters from the machine. Calculate the velocity of the ball as it is projected from the machine. So the velocity of the ball as it is projected is u, and that's actually equals to the horizontal velocity, the initial horizontal velocity. Okay, so that's something that we just discussed actually. Okay, and then we know that the horizontal direction has only one equation, Sx over uxt. And we need to find ux here. So I'm going to make ux the subject. So Sx divided by t. Okay, the horizontal distance to go from A to B, they have given to us. And we know the time taken to go from A to B, we found out. So we just have to plug those in. So 17.89 times 0.72. And that's going to get me the answer as 24.8 meter per second. Okay, so that's all for part A. Now let's go to part B. In part B, it says the initial velocity of the ball as it is projected from the machine can be increased. Explain how increasing the initial velocity would affect the angle at which the ball hits the ground. So here we have the ball and it hits the ground. Okay, and then when it hits the ground, it's going to have a velocity v, and it's going to have two components, Vy. Let me change the color. It's going to have Vy and Vx. And this is going to be the angle that is formed when the ball hits the ground. Okay, so a couple of things let me write down first. Okay, is when the initial velocity increases, Vx increases, and then Vy is not affected and stays constant. Okay, and then number 3 I will explain at the end. Okay, let me explain these first 2 points and then we'll get to the last one. So you will get 1 mark for this and 1 mark for this. Now let me explain this. So why does Vx increase? Well, that's because Ux is going to increase, and Ux and Vx is basically the same thing, right? Because in the x direction the acceleration is equals to 0. Okay, so remember that the initial velocity is equals to Ux. Now, if the initial velocity is going to increase, then obviously the initial horizontal velocity will increase, because remember at the start, u of y is equals to 0. So if uy is equals to 0, then ux is equals to the initial velocity. So that's why Vx increases. Now let's talk about why Vy is not affected and stays constant. So for this, I'm going to explain a little bit more in detail. Let's look at this a bit more in detail, because the mark scheme doesn't explain it too much, and you might wonder why is the vertical velocity increasing, decreasing, or constant. We're going to see that. Okay, so we have 2 situations. One where we have Ux and then the Ux increases. Okay, so we have 2 situations. Now let's see what the final velocity, vertical velocity, is dependent on. So we know v square is equals to u square plus 2as. Now we know that the u is 0, the velocity in the vertical direction initially is 0, so this cancels out. So we get v is equals to square root 2as. Now this s is the displacement in the vertical direction. Now in both of these situations, the vertical displacement s is going to be equals to minus 2.54. Here also s is equals to minus 2.54. Okay, I hope that's clear. So our 2a is constant and our vertical displacement is also constant. So our velocity in the vertical direction should be constant. Okay, so our velocity in the vertical direction is dependent on the vertical displacement, which we already know is constant. It is constant. Okay, second equation we can make use of is v is equals to u plus at. Now u again cancels out, v is equals to at. So a is going to be constant and t here is going to be the time of flight. Okay, t is going to be the time of flight. So number 2, time of flight, basically how much time it spends in the air. Okay, so remember the 2 points we're talking about. This is the initial point, this is the final point. Initial point, final point. Okay, so keep that in mind. Okay, so time of flight. Now we don't know if this is going to increase, decrease, or stay constant. Okay, as the ux is going to increase, we don't know what's going to happen to time of flight. Okay, now we have to check if the time of flight remains constant, what happens to it. And for this, we have been given a hint to check the horizontal equation. So sx is equals to ux t. Okay, now we know the ux is going to increase, so sx should also increase. The horizontal distance traveled is going to increase. So our t is going to remain constant. So t is constant. Okay. Now, it says the final vertical velocity, does it increase, decrease, or stay constant? So we know that our sy is constant and our time of flight is also constant. Since we know that v is equals to square root 2as and v is equals to at, talking about the vertical direction, and if this is constant and this is constant, then our final vertical velocity is also constant. Hence we can say our final vertical velocity is constant. Okay, so now we come back to the question. I hope you understand the first and second point. Now, I'm going to take this, I'm going to draw a triangle for this. So, we have our Vx, we have our Vy, and then we have the resultant. Vx, Vy, and V. And this is going to be theta. Now we know tan theta is equals to Vy over Vx. Okay? Now, since our Vy is constant, what we can say is that if Vx is increasing, then tan theta should decrease. And if tan theta is decreasing, then theta should decrease. Okay? So that's basically your last mark. That's the third mark basically. Now you can also, some students, they can also take this angle. Okay, it really depends. Whichever you go with, your answer will change, and both are acceptable. So when you take this angle as theta, you're gonna get your triangle like this. Okay, and this is gonna be your theta. V, Vy, Vx, and then for this, you're gonna have tan theta is equals to Vx over Vy. Vy is constant, Vx is gonna be increasing, so tan theta increases. So tan theta is increasing, so theta is increasing. Okay, so you can pick one as the theta, and yeah, so that's how both of those are going to work. You can write any of those for the answer. So I hope that's clear. Now the other way you can do this question is by drawing these diagrams. So you can see here I've kept Vy same in both of the triangles. These are vector triangles, and Vx has increased, so I've increased the length, and then V has also increased. Okay, the reason that the final resultant velocity is going to increase is because Vx increases. Okay, now if you notice here, the theta here is decreasing and this theta is increasing. So this theta, or let's change it, let's call it alpha, so we don't get confused. Okay, let's call this alpha. Okay, so you can notice that going from triangle 1 to triangle 2, alpha increases and theta decreases. It might not be very noticeable, but that does happen, and we can see that through the equations as well. Okay, another way to understand this is that as the Vx is going to increase, the V moves closer towards the Vx, so that this angle is going to decrease, and this angle is going to increase. Okay, so I honestly prefer this way. It's a bit easier, but if you want, you can draw the triangles as well. That's acceptable. So any of these three ways the mark scheme says is acceptable. Okay, so let me just write the answer down in a proper way. This is just a quick way to write the answer, and after that we'll end the video. So this is going to be your answer. The horizontal component of velocity Vx increases, Vy stays the same and is independent of the initial velocity. Tan theta is equals to Vy over Vx, hence tan theta decreases, so angle at which the ball hits the ground decreases. Okay, so one mark, then the other mark, and then the third mark. Okay, so that's going to be the answer to this question. Now I'm going to show you the mark scheme and examiner report.